Hello everyone, welcome back to today's session on economic analysis in irrigation and water resources engineering. In this video, we will learn about estimation of costs and evaluation of benefits in irrigation projects. Every irrigation project, where it is a dam, canal system, reservoir, etc., requires huge investment. Therefore, engineers must carefully analyze whether the project is economically feasible before implementation. Economic analysis helps us to compare project cost with expected benefits such as increased crop production, groundwater recharge, and flood protection. In today's session, we will understand cost components, evaluation methods, benefit analysis, and an important decision-making tool called benefit cost ratio or BCR. By the end of this video, you will understand how engineers evaluate irrigation projects from an economic perspective. Before discussing calculation and economic models, let us understand the perspective of farmers who are the primary beneficiaries of irrigation projects. Farmers require reliable year-round water supply to grow crops successfully. In many regions, agriculture depends heavily on seasonal rainfall, making farming risky and uncertain. Irrigation projects provide stability and support multi-cropping possibilities, allowing farmers to cultivate more than one crop per year. However, farmers are also concerned about maintenance costs, water charges, and fair distribution of water. Their ultimate goal is stabilizing agricultural economy by improving income and livelihood security. This stage reminds engineers and planners how economic analysis is not only about numbers and profits, it is also about improving the quality of life for farming communities. Understanding stakeholder needs helps in designing sustainable and socially beneficial irrigation systems. Now let us define the major cost components involved in irrigation projects. Costs are generally classified into capital cost and annual cost. Capital cost include major initial investments such as dam construction, land acquisition, canal networks, spillways, and infrastructure development. These costs are usually very high because irrigation projects involve large-scale civil engineering works. The second category is annual cost, which includes interest on capital, investment operation and maintenance expenses, repair works, salaries and depreciation of structures over time. Maintenance is extremely important because poorly maintained system reduced efficiency and project life. Economic analysis requires accurate estimation of both initial and recurring expenses. If costs are underestimated, the project may become financially unsustainable in future. Therefore, engineers must carefully calculate all direct and indirect expenditures before approving a project. After understanding the cost, the next step is selecting suitable evaluation methods. Economic evaluation helps determine whether the benefits generated by a project justify the investment. Engineers use several methods such as benefit cost ratio, net present value, and internal rate of return. These techniques compare project expenditure with expected returns over time. Today, modern technologies and GenAI tools are also being used to generate feasibility framework for sustainable irrigation planning. These systems analyze rainfall patterns, crop requirements, groundwater conditions, and economic performance to support decision making. Evaluation methods also consider environmental and social impacts in addition to financial returns. A project may generate moderate financial profit but still be valuable because it improves food security, rural employment, and drought resilience. Therefore, economic evaluation combines technical, social, and environmental perspectives to support sustainable development. This slide explains cost modeling in irrigation projects. Cost allocation is divided among different project components. According to this example, primary structures such as dams and headworks consume about 55% of total cost. The distributory canal system accounts for 25% because it involves transportation of water to agricultural fields. Maintenance funds contribute around 12%, while administrative expenses take about 8%. In addition, operation and maintenance costs are estimated to about 1 to 2% of the total capital investment annually. Cost modeling helps engineers understand where resources are being utilized and how to optimize the expenditure. It also supports financial planning and budgeting throughout the project lifecycle. Accurate cost modeling is important because of irrigation projects are long-term investments that require sustainable financial management. Economic analysis is incomplete without evaluating project benefits. Benefits are generally classified into direct and indirect benefits. Direct benefits include increased crop yield per hectare, improved agricultural productivity, and higher value crop rotation. Therefore, engineers must evaluate both tangible and intangible benefits while assessing project feasibility. A successful irrigation project should create sustainable economic growth while protecting environmental resources. In this slide, we shall study about one of the most important factors in decision making tools in economic analysis, that is the benefit cost ratio, commonly called BCR. This ratio compares the total benefits of a project with its total cost. The formula is very simple: the total benefits divided by total cost. If the BCR is greater than 1, the project generates more benefits than the cost. According to Indian irrigation project standards, a BCR greater than 1.5 is generally considered economically feasible. However, in drought-prone regions, projects with BCR slightly above 1 may also be accepted because they provide essential social and environmental support. BCR helps policymakers and engineers compare multiple projects and prioritize investments. It acts as a quick indicator of economic viability and long-term sustainability. Let us summarize the important points discussed today. Economic analysis is essential for evaluating irrigation projects before implementation. The process begins with understanding stakeholder needs and farmers' perspective. Costs are classified into capital costs and recurring operation and maintenance expenses. Benefits includes both direct and indirect social and environmental improvements. Engineers use evaluation methods such as benefit cost ratio to determine project feasibility. The session also highlighted the importance of balancing financial performance with social welfare and sustainability. Overall, economic analysis ensures that irrigation projects are technically sound and financially feasible and socially beneficial. Now let us test our understanding with a quick activity. Here is a puzzle. A project annually benefits of 10 million rupees, an annual cost of 8 million rupees. Is the project viable? Understand Indian criteria. The benefit cost ratio is calculated as 10 divided by 8, which equals to 1.25. Since the value is below the standard benchmark of 1.5, the project may not be normally considered as economically feasible. These are the important references used for this presentation. Students are encouraged to study these materials for deeper conceptual understanding. To conclude, economic analysis plays a major role in irrigation engineering because it helps ensure efficient utilization of financial resources while maximizing social and agricultural benefits. Proper estimation of costs and evaluation of benefits lead to sustainable and successful irrigation projects. Thank you for watching this session. I hope this video helped you clearly understand the importance of economic analysis in irrigation and water resources engineering. See you in next class. Have a good day.